Welcome back everyone, and we are continuing with converting. So at the end of the last video, we converted from standard form to vertex form. We're now going to start this video with converting from vertex form to standard form. So we're going to go from y equals a times x minus h squared plus k to y equals ax squared plus bx plus c. Now, I will let you guys know, there is a little bit more involved in this one, all right? There's not just, oh, plug stuff in. So, here are the steps. You need to separate the x minus h squared into two binomials. So, this is going to be written as x minus h times x minus h. Then, you are going to multiply the two binomials together. Everything from the first gets multiplied to everything in the second. And then finally, you'll simplify by combining like terms. So, y equals negative 3 times x minus 5 squared plus 12. So the first thing we need to do is separate x minus 5 squared into two binomials. We're going to keep minus 3 on the outside. So we have y equals negative 3, x minus 5 plus 12. Anytime you have something in front of the parentheses, I highly recommend starting with multiplying that to one of the binomials first. So we're going to multiply negative 3 to x minus 5, just the first one. So we're going to have negative 3x plus 15, x minus 5 plus 12. We're not going to do anything with this plus 12 until the very end. But now we have two binomials. We need to multiply them together. Everything from the first gets multiplied to everything in the second. So let's start with negative 3x, multiplying it by both items in here. Negative 3x times x is negative 3x squared. Negative 3x times minus 5 is plus 15x. Then we need to take the 15 and multiply it by both x and minus 5. 15 times x is plus 15x. 15 times minus 5 is minus 75. And then we still have that plus 12. So now our final step is combine like terms. So 15x and 15x are like terms. And then minus 75 and 12 are like terms. So we have y is equal to negative 3x squared plus 30x minus 63. And that's how we convert from vertex form to standard form. All right, now the big ones, the big stuff, what we need to be able to find to be able to graph in the next lesson. Key features of a quadratic function in vertex form given an equation. So just like in standard form, we're going to find all the key features. But there's going to be some different ways how to do this. So you need to make sure you know how to identify the different items here. So again, vertex form is y equals a times x minus h squared plus k. All right, how it opens. This has stayed the same. If you have a positive a, it opens up. If you have a negative a, it opens down. All right, now we have to find the vertex first before axis of symmetry. Remember, our vertex is HK. And remember, H is opposite. Axis of symmetry is going to be x equals whatever h is. Minimum and maximum. Remember, this depends on if it's opening up or down. If it is opening up, you have a minimum. If it is opening down, you have a maximum. And once you select which one it is, then you will write whatever the value is at the k value. And that's coming from your vertex. All right, here's where there are changes. In standard form, you would use the quadratic formula. You're not going to do that here. There's a different procedure for X-intercepts in vertex form. The new procedure is this. Plug 0 into y and solve for x. So we're going to be doing some solving. We're going to be plugging 0 into y and then getting x by itself. And then for the y-intercept, same thing. This is going to be different. As you can tell from our vertex form, we do not have a c value. So there is going to be a different way to find the y-intercept. And that is plug 0 into x and solve for y. So you want to make sure you're using the correct items to find the x and y intercepts. Domain has not changed. Negative infinity to positive infinity. That never changes. Range, remember, range is dependent upon if it is a minimum or a maximum. If it is a minimum, then your range is bracket k to infinity. And if it is a maximum, you start at negative infinity and it goes to k with a bracket. So now that we know how to identify all our key features, I have one example to close out this video, and then there will be an extra example if you feel like you need an extra example. So, all right. Make sure you have these written down, because I will have to cover them while I do our next example. All right. So using the equation y equals x minus 2 squared minus 9, identify all the key features of the quadratic function. So you don't have to go in order. I like to find all the easy ones first and then do my work next. All right, so opens. Since it is positive in front of the parentheses, this opens up. My vertex is going to be, remember, opposite of inside the parentheses. So opposite of negative 2 is positive 2, and then minus 9 stays the same. Axis of symmetry is just going to be x equals 2. All right. Since it opens up, this is a minimum at my k, also known as my y value, so at negative 9. All right, roots and y-intercept I will find in just a moment. So let's fill in domain and range. Domain is always negative infinity to positive infinity. And then range. Since it is opening up, it is a minimum. So that is what my range needs to be. It's going to be bracket negative 9 to positive infinity. Now to find the roots and the y-intercept. Remember, roots are just the x-intercepts. Their names mean the same. So, for the roots, we plug 0 into y. And solve for x. So the first thing we do is we're going to add 9 to both sides. So we have 9 is equal to x minus 2 squared. Then, since x minus 2 is all squared, to get rid of a square, we square root both sides. Now, remember, when we take the square root, we're going to have plus or minus, and then the square root of 9 is 3, is equal to x minus 2. Since it's plus or minus, that means we're going to have two answers. So we need to separate this into two equations. X minus 2 is equal to positive 3, and x minus 2 is equal to negative 3. Plus and minus 3. Now we solve for x. Add 2 to both sides for both of them. So we get x is equal to 5 and negative 1. But these are roots, these are coordinate points, so you need to write them as coordinate points. So 5, 0, negative 1, 0. And those are our roots. Now for the y-intercept. This one, we're going to plug 0 into x. So y is equal to 0 minus 2 squared minus 9. I like to do just a slight little simplifying inside the parentheses before I plug into my calculator. So then negative 2 squared minus 9, and we end up with negative 5. But again, this is a point, so it's going to be at 0, negative 5. And there you go. If you would like to see one more example of finding all the key features, watch the next video. If you are good to go, you do not have to watch the last one.